Hi, my name is Jim Pollitt. I work for the Department of Municipal Affairs and Environment, Water Resources Management Division for the Government of Newfoundland and Labrador. I am here today to talk to you about sodium hypochlorite solution preparation. Disinfection of public drinking water systems in Newfoundland and Labrador is mandatory. Various methods of disinfection are utilized throughout the province, including chlorination, ozonation, chlorination, and ultraviolet radiation. However, chlorine is the most common form of disinfection used in the province. The two main chemicals utilized for chlorination are chlorine gas and sodium hypochlorite, commonly referred to as liquid chlorination or hypochlorination. To ensure drinking water is being adequately disinfected, operators of drinking water systems need to monitor chlorine dosage and chlorine residual levels. Chlorine residual is the amount of chlorine remaining in the water in the distribution system after chlorine demand has been met. Daily monitoring of chlorine residuals verifies that your chlorination system is operating effectively and the safety of your drinking water is protected. Daily monitoring, including weekends, is required under your permit to operate. If you operate a hypochlorination system using sodium hypochlorite, proper preparation and handling of your solution is vital to ensuring that effective chlorination is achieved. Today, I will demonstrate the correct procedures for preparing a sodium hypochlorite solution for use in a hypochlorination disinfection system. A hypochlorination system primarily consists of a chemical metering pump, a solution tank, and a flow meter when flow proportioning is desired. The operational parameters of the system involve three controllable variables. The first two controls are functions of the chemical metering pump. They are the pumping rate and the stroke length. The third control is the strength of the chemical solution. The pumping rate is the frequency of the pumping strokes, usually displayed in strokes per minute. With systems of varying flow, a flow meter is used to automatically adjust the pumping rate of the chemical feed pump. This is done to match flow variations in the water distribution system, such as low flows experienced overnight and high flows experienced in the morning. When the flow in the distribution system is uniform, the pumping rate can be held constant. The stroke length control is used to increase or decrease the amount of chemical being injected by the chemical feed pump on each stroke. Chemical feed pumps with the stroke knob button on the front are manually adjusted by turning the button to the required setting. The pump is graduated from 0 to 100%, but the operating range is usually from 20 to 100%. Some metering pumps have microprocessor technology, which requires reprogramming of the injection rate by the use of the menu buttons. This is the only variable control that we recommend be adjusted to increase or decrease chemical injection on a daily basis. The strength of the chemical solution used to produce the chlorine residual in the drinking water distribution system is the remaining control in the hypochlorination process. This parameter should also be kept constant. Maintaining a consistent chlorine concentration in the disinfection solution tank is very important in achieving consistent chlorine residuals in the water distribution system. The only time that the strength of the chemical solution should change is when the chlorine demand exceeds the adjustment capabilities of the stroke length control on the chemical feed pump. This may occur during periods of poor water quality, such as pond turnover, or during adverse weather conditions. The chemical solution should then be strengthened or weakened accordingly. The new solution percentage would then become the normal mix moving forward. The chemical being used today is sodium hypochlorite. It is a common household chemical, also known as bleach. Bleach can be bought in grocery stores where the solution strength is approximately 5.25%. For drinking water disinfection systems, a stronger commercial product of 10.3% solution strength is used. The sodium hypochlorite product has to be certified to the NSF standard 60. Please note, the type of bleach available in grocery stores is not NSF standard 60 and is not appropriate for use in drinking water. When purchasing sodium hypochlorite from a chemical supplier, Please ensure the product is NSF Standard 60. The NSF Standard 60 should be stamped on the label. The chemical supplier should also provide you with a safety data sheet for sodium hypochlorite. If you require help acquiring sodium hypochlorite or wish to verify the product you are using meets the required standards, please contact the operator trainer in your area. It is common practice to dilute the sodium hypochlorite solutions with water for use in the disinfection systems. This is done when weaker concentrations can achieve the chlorine residual required. The benefit of this approach is a more evenly distributed injection of the chemical into the water flow. At this point, we should discuss some important properties of sodium hypochlorite which can affect its performance as a disinfectant. Sodium hypochlorite will degrade over time, both in the mixing tank and also in the stored unopened containers. It is good practice to buy a fresh supply on a regular basis and cycle containers so that the old stock is used up first. It is also good practice to only mix enough disinfection solution to last approximately 1 week. The refill mark should be near the bottom of the tank but above the foot valve for the pump intake. The temperature at which the chemical is stored will significantly affect the strength of the sodium hypochlorite. Increased temperature will increase the degradation rate of the chemical. The same is true for exposure to light. It is recommended to store the sodium hypochlorite in a cool, dark place. The chlorine facility needs only to be warm enough to avoid freezing of the system. Elevated pH levels will decrease the effectiveness of the disinfectant. If you chemically adjust the pH of your water using lime or soda ash, this should be done after the injection of the sodium hypochlorite solution. Sodium hypochlorite is a corrosive chemical which requires appropriate personal protective equipment during handling. This equipment should include rubber boots, a full face shield complete with chemical splash goggles, or a full face respirator, chemical resistant gloves, and an apron or a rubber suit. The mixing area should be well ventilated and equipped with a shower and an eye wash station. Contact lenses should not be worn when handling sodium hypochlorite, and it should never be mixed with acid as the chemical reaction will create a toxic chlorine gas. Take time to review the safety data sheet for your own sodium hypochlorite product before use. The solution tank should be made of plastic such as polyethylene or other chlorine-resistant materials and conform to the NSF Standard 61 for chemical tanks. It should hold at least 1 week's supply and be placed in a cool, dry area. The cover should prevent contamination by dust, debris, and insects. The tank should be cleaned and washed at regular intervals. The solution strength you require will vary according to the properties of the source water. It can also vary seasonally for a particular water system. You need to determine the mixed strength ratio that will produce the required chlorine residual within the dosing rate capabilities of our chemical metering pump. That is, our metering pump should be able to supply the required liters per hour of chemical to achieve the desired chlorine residual. As a starting point, we recommend a solution concentration ranging from 0.5% to 2%. If your water source is high quality without dissolved organic compounds, such as groundwater, you may want to start with the weaker concentration. For surface water sources containing dissolved organic compounds, which may cause the water to appear colored, a 2% concentration would be more appropriate. If you require assistance, your local operator trainer can assist you in choosing your starting disinfectant concentration. For this training video, we will assume a required concentration of 2%. A mix ratio of 1:4 sodium hypochlorite 10.3% to water will yield this concentration. Set the chemical metering pump at 65% for pumps with a stroke length knob. This is the midway point of the operating range. Pumps with microprocessors to control the dosing amount should be set at 50% of total output. This allows for equal amounts of dosing range for increasing or decreasing injection amounts. To mix a 2% solution in our tank, we have to measure the volumes of sodium hypochlorite and water. For best results, use a graduated cylinder for measuring both liquids. We will use a container graduated in liters. To create our mix ratio of 1:4 sodium hypochlorite 10.3% to water, we measure 4 liters of water and add it to the tank. We then measure 1 liter of sodium hypochlorite and add it to our tank. We have now created 5 liters of 2% hypochlorination solution. Begin the disinfection process and then measure the chlorine residuals in your system, allowing enough time for the chlorine solution to travel through your distribution system. If this concentration yields the desired chlorine residual, we can continue chlorination at this solution strength. If the chlorine residual is too low and we increase the stroke length adjustment to 100%, we need to increase the concentration of the disinfection solution. If the chlorine residual is too high and we have decreased the stroke length adjustment to the minimum, in this case 30%, we need to decrease the concentration of the disinfection solution. Remember, the only time that we should change the concentration of the disinfection solution is when we are establishing or adjusting the required disinfectant concentration strength as required by the chlorine metering pump injection rate capabilities. This will occur when we are setting up a new system or when changes to our source water quality change the chlorine demand and we have reached the maximum or minimum limit of the metering pump while requiring further adjustment. When we have established our optimum solution concentration, we need to establish the amount of solution we will need for a 1-week supply. To do this, we will need to be able to measure the amount of solution used over a measured period of time. This will establish a rate of use. We can do this by calibrating our solution tank if it does not have existing calibration markings. For a uniform cylindrical tank, simply use a tape measure to graduate the tank into equal volumetric segments, that is 5, 10, or 20 liter segments. To do this, we need to add a known volume of solution to the tank. We can then measure the rise of the liquid in the tank. For this demonstration, based on our tank size, we are using 5 liter increments, which result in a 26 millimeter rise in our tank level. We can now graduate our tank by marking 26 millimeter increments for each 5 liters. If the tank is non-uniform or conical in shape, consult your local operator trainer regarding proper tank calibration. Choose an appropriate time interval such as 24 hours and measure the amount of solution used by observing the markings on the tank. Apply the rate of take over a 7-day period to establish the volume required for a 1 tank turnover in 1 week. This is the volume we should mix each week during the operation of a system. For example, a tank is measured after 1 day or 24 hours and 15 liters of solution has been used. This would equal 15 liters per day times 7 days per week, which totals 105 liters per week. Divide the 105 liters per week by 5 liters of 2% solution in each batch as previously described, and we have to add 21 batches in total. Each batch requires 1 liter of sodium hypochlorite 10.3% and 4 liters of water. Therefore, for a 1-week supply of solution, we have to add 21 liters of sodium hypochlorite and 84 liters of water to our tank. If we have our tank graduated, we can add the water by using the measurements on the tank to add the correct amount. For a uniform diameter tank, we can use the tank markings to create a tank gauge. The gauge can be taped to the side of the tank with the 0 at the existing solution level. This would eliminate the need for interpolation. The following are examples of solution strength for common sodium hypochlorite 10.3% to water mix ratios. 1 sodium hypochlorite to 3 water equals 2.5%. 1 sodium hypochlorite to 2 water equals 3.3%. 1 sodium hypochlorite to 1 water equals 5%. The hypochlorination system is now ready for operation. It should have the optimum solution concentration to control the chlorine residual during operation. Any adjustment of the chlorine injection should only be made using the stroke knob or the injection rate programming in pumps with this type of electronic control. For additional training on hypochlorination systems, contact the operator trainer of your region. For more information related to mixing sodium hypochlorite solutions or operating sodium hypochlorite disinfection systems, please visit the Department of Municipal Affairs and Environment website.